Good morning to all. I'm Dr. Navina Priyadarshini, Professor of EC Department, Rohini College of Engineering and Technology. So in today's class, we are going to discuss about the OFDM. OFDM stands for Orthogonal Frequency Division Multiplexing. So this OFDM is an efficient multiplexing as well as modulation scheme, highly used for 4G as well as 5G communication system. So here it is mainly used for frequency selective channels. So the main idea behind this OFDM is to divide a broadband frequency selective channel into a number of narrowband subchannels using the fast Fourier transform. So to obtain, because of this, the spectral efficiencies get increased so that the frequency response of the subcarriers are overlapping and orthogonal. So hence it is named as OFDM. So here the subcarriers frequencies will be always orthogonal to each other. This orthogonality is maintained with the small compromise in this loss in SNR, even though the signal passes through a time dispersive fading channel. So because of the main reason is here it uses the cyclic prefix. So the part of the each each packet that is placed in front of each packet. Because of that, the signal loss as well as collision may occur. The original data has been protected from loss during transmission. So the block diagram of this OFDM system is shown in this figure. So here this is the block diagram of OFDM system. So here the first of all the input data that is received from the source and that is converted into a digital format. So in OFDM it accepts only the digital signal. It will not accept any analog signal. So first of all the signal from the source is generated and then it is converted into digital form, and the digital signal is passed through the channel coding or a mapper. So here first of all any one of the modulation schemes are employed. So the most commonly used modulation is either BPSK or QPSK. Sometimes QAM is preferred. So based on the application where we are applying this OFDM scheme, based on that the modulation schemes are chosen. So the first, the incoming signal is modulated by using any one of the digital modulation scheme. So next the guard bands are inserted. So once the signal is modulated, produces the modulated waveform, and for each data packets in between the data frames we are including the guard bits. Next the signal is given to the serial to parallel converter. So here the incoming serial signals are divided into split into number of parallel data, and it is given to the next stage. So next the IFFT operation is performed on the received signal. So in some cases the IFFT is done. If it is a discrete data, then the IDFT operation is executed. So here the incoming signal will be a wideband signal. So this is now converted into a narrowband signal. So each narrowband signals are modulated by using some frequencies. The frequencies are harmonics of frequencies, so it will not get interfere with each other. So each subbands are multiplied by the subcarriers and it is given to the parallel to serial converter. So once the signal is passed with parallel to serial converter, the the serial data is generated, and then the guard cyclic prefix is added. So sometimes cyclic prefix or zero padding is done. So the most commonly used method is the cyclic prefix. So in cyclic prefix, so that some tail bits of each data packets are copied and that are placed in front of each data packets. So because of that, in case any collisions occurs during the transmission, the loss of data is get avoided. We can recover our data safely. So after cycle prefix insertion, it is given to the digital to analog converter and it is transmitted through the channel. So in the channel, it may be a fading channel, and here the channel addition of noises will be there. And at the receiving end, the just reverse operation, what we have done at the transmitting end, whose reverse operation is executed. So first of all, the received signal is given to the analog to digital converter, thus the digital signals are produced, and the added cyclic prefix are removed here. Then it is given to the serial to parallel converter. So the incoming signal data stream is divided into number of streams, and the DFT operation is done so that the address of carriers are removed and it is given the parallel to serial converter. Therefore, the serial data is given to the guard band removal session. And once the guard band is relieved, then it is given to the channel decoding and demodulation scheme. So after decoding and demodulation, the original data is received as such. So these things are explained here. So in which because of this orthogonality among the subcarriers is maintained, the perfect data transmission is achieved. So if it is collapsed, then the loss of orthogonality which causes the intersymbol interference, which degrades the bit rate performance. So FDM transmitters and the FDM receivers that we have discussed in this figure itself. So this is the FDM transmitter. So first of all, the same there is a receiver. So the received signal is get incoming signal is received by the antenna and it is transmitted through the low pass filter and it is given to the demultiplexer and then it is given to the analog to digital converter and once again FFT operation is performed and at the end the signal is uh, combined and it gives to the desired destination. So thus this returns the n parallel streams, each of which is converted to a binary stream using the appropriate symbol detector. So these streams are then recombined into a serial stream, which is an estimate of the original binary signal of the transmitter. Thus the transmitter signal is received safely at the recovered safely at the receiving end. Thank you.